Now I'm going to practice writing equations from graphs. Let's see if we can figure this out together. I got 3 graphs here. I want the equations for all 3 of these. And you have that in your notes like this, but I'm going to break them down into one page at a time. So let's take on the first one. And we're going to see this guy here. So if we want this equation, we need to know the parameters, the amplitude, the period. Is there a phase shift? Is there a vertical shift? All of that depends on the box. So you got to spend some time figuring out your box. You need a box with one complete cycle. Okay, well, that's not really complete cycle. I don't really have it right. Now, actually, I could go from here to here. And if I adjust the height and the width, there is a box. And it captures a complete wave. It starts at the bottom, ends at the bottom, and I have a complete cycle in that box. And there is an equation for this graph based on that box. The amplitude, the period, the phase shift, all of that can be factored in. However, because the box has been shifted over here on the right side, the box is on the right means I have a phase shift. And having a phase shift is going to make it a little bit harder. If I move the box to the axis, then there is no phase shift. So this box has an equation that's slightly different than that equation. That box has a different equation, and they're both going to create the same wave graph. But this box is going to be easier for us. So let's limit ourselves to this no horizontal shift here. That makes our life easier. And let's create the equation of this box. Okay, so let's start recording what we can find out about the wave. And part of that includes figuring out the amplitude, the midline, and the period. So it's a good place to start with the midline. And I see a midline right here. Midline. Y equals -1, which means there's a vertical shift. The vertical shift is -1. Okay, that'll be important. Next, I need to know the amplitude. So the amplitude. The amplitude is from the midline to the top, which is 3 units. Same with going from the midline down, it's also 3 units. So basically the midline is half the box height. Next is the period. What is the period? Well, fortunately, because we started on x equals 0 as our start, and we went to x equals pi as our end, we have an easy period calculation. Pi minus 0 is 0 pi. The period, the width of the box, is pi units wide. One other easy thing that we got to come up with is the phase shift. Now, because we were strategic and we started the box at 0, the phase shift is 0, and that's going to make our work a lot easier for us. Okay, so we are ready to begin. We need an equation for this. Y equals A. Oh, I forgot one more piece of information in the box. What kind of wave is it? So we have to determine, what trig function are we dealing with? And since the trig graph starts at the top, there's only one trig function that does that, and that's cosine. So that's going to involve our equation. So our equation is going to be a times cosine of bx plus c plus d. All we need is these numbers here. Okay, so amplitude, that equals 3 And so A is pretty straightforward. A is 3, 1 down. The vertical shift was -1. That's also very straightforward. That affects the downshift. That's a vertical shift down, so D is -1. So we got 2 of them knocked off really quick. The rest take a little bit more work. When you look at all these parameters, amplitude, period, and phase shift, C is not in there and B is not in there, not necessarily. In general, you have to work for B and C. They're not on the picture. You have to solve B and C by formulas. Okay, I want to drive this point home one more time. These parameters, the midline, amplitude, period, phase shift, and vertical shift, they don't necessarily directly give us B and C. A and D, yes, but not B and C. B and C, we have to work for those 2 coefficients, or those 2 terms there. So B, though, is tied to a formula, and the formula is tied to period. And we know the period, it equals pi, and we know the formula is 2 pi over B. So we can use the formula to find B. So we always have to solve for it. Now some students go really fast and don't pay attention, and when there's fractions that aren't quite as nice, they get their fractions messed up. So just be thoughtful and careful on this. But we get B times pi equals 2 pi. And then lastly I'm just going to divide by pi. So B equals 2. So we got 3 of them so far. We need 1 more. And we need the C number. Now in this one, the C happens to be easy because the phase shift started at 0. There is no phase shift, so there is no C. So intuitively, you might be able to go immediately there and say C is 0 and be done with it. But I'm going to show you how to find C, because when they're harder, we'll be needing the formula. So we do have a formula. Phase shift equals -C over B. And I can use this formula to solve for C. Now phase shift we've already established from the box equals 0. And -C, I don't know what C is yet, but B I just found. So I'm going to plug in the 2. And then I multiply to get C by itself. -2 on both sides. And -2 times 0 is still 0. And -2 times -C over 2 is C. There I found C was 0. So I found it algebraically, and over here I found it intuitively, but I got all the parameters. Alright, so I have my equation. Y equals A, which is 3 cosine of B is 2. There is no C value I need to worry about. And plus D, D is -1. And there I have my equation. So that's the equation for that graph right there.